This is Unit 3, linear relationships. So relationships of two properties that form a straight line. That relationship creates a line, or you can see that relationship on a line. Graphs of proportional relationships. So it's drawing that line. So graphs of proportional relationships. And in this case, activity 1 is an unknown situation. So what do you know about this situation just by looking at this graph? Well, first of all, you know that it's a proportional relationship because it's linear, it forms a line, and it goes through 0, 0. So what that means is if you double the, let's look at a few points on the line, and then we'll talk about what that means in a moment. So this point right here, 4, and you go up here to 7. Notice this is every two lines are labeled. So this is 2, 4, 6, 8. So this is 7 right here. So along the x-axis it's 4, along the y-axis it's 7. So now proportional relationship means if I double the x value, if I double whatever this property is along the x-axis, and we've looked at time, we've looked at distance, and various other things, if that gets doubled, so now it's going to go from 4 to 8. It's going to go from this 4 to this 8. Notice on the line, the y value, whatever that is, whatever property is along the y-axis, also gets doubled. So that goes from 7, 2 times 7 is 14. So this goes to 8, 14. And notice once again, if we double these two coordinates, 2 times 8 is 16. So 2 times 8 is this 16 out here. And 2 times 14 is 28. So 2 times this 14 takes you up to 28 up to here. So 2 times this 14 gets you to 28. So proportional relationship means that both properties are related through the same factor. If you double one property, if you double time, then you double distance. If you triple the time, then you triple the distance. If you take 1/2 the time, then you travel 1/2 the distance. Things like that. So those are proportional. And we know that there's no moving of the slope triangle, which makes proportional relationships, the graphs of those proportional relationships and the equations of those proportional relationships much easier than what we've been dealing with. Because now the vertical distance is the y-coordinate. So this is the y length, the vertical distance is equal to 14. That is the y-coordinate. It's 14. It's right there because this has already been slid over to 0, 0. So the y-coordinate goes and the equals the y-coordinate because the line, the graph, goes through 0, 0, goes through the origin 0, 0. And the horizontal distance is the x-coordinate. So this distance from 0 to 8, that's the x-coordinate. It's right here, this 8. That is also the horizontal distance. You don't have to slide it over. You don't have to add anything. You don't have to subtract anything. It is the horizontal distance. That's an important point because when you go to write the equation, first of all, the slope is the vertical distance, the ratio of the vertical distance to the horizontal distance. So now you just have to look at the coordinates. Any of these will work. So let's take 14 to 8, that ratio. Now notice what you're doing. You're subtracting 0. 14 minus 0 is 14. So it is that coordinate, the vertical distance. The horizontal distance is 8 minus 0. So this 8 minus this 0. So the horizontal distance is that coordinate, 8. So that ratio, 14 to 8, if you simplify it, it simplifies to 7/4. So you can take any of these coordinates, and all you have to do is write the y-coordinate over the x-coordinate. And again, can't say this enough, because it goes through 0, 0, that is the slope. Y, the ratio of y to x equals the slope. So 28 to 16, 14 to 8, 7 to 4, those are all equivalent ratios. And they also tell you what the left side of the equation is, the side with the x's and the y's, because it's y minus 0 is y, x minus 0 is x, so the ratio of y to x is equal to 7/4. So the ratio of y to x equals 7/4. The ratio of y to x equals 7/4. And now if you just say in words what that means, it means that the vertical distance is 7/4 the horizontal distance. So the horizontal distance is 4/4, and the vertical distance is 3 more fourths of that. So if you take 8, you divide 8 into 4 equal parts. Each part is equal to 2 parts. One part, 2 parts, 3 parts, 4 parts. And then 14 is 3 more of those parts, or 6 more beyond 8. 8 plus 6 is 14. So 1 part, 2 parts, 3 parts, 4 parts. That's 4/4, 5/4, 6/4, 7/4. So this length, the vertical distance, is 7/4 of the horizontal distance, which is 4/4. So it's 3/4 longer. It's easier to look at, or it's better to look at it as multiplication. So it's 7/4 of the horizontal distance. So then you can just write what you're saying as in mathematical terms. So y, the vertical distance, is or equals 7/4 of the horizontal distance. And we're going to go through some algebra of why you can move this x over to here. But at this time, it's actually easier just to see it verbally what you're saying and just write those words as the equation. So the vertical distance is equal to 7/4. It's longer than the horizontal distance. It's longer by how much? It's 7/4 of the horizontal distance. You could also say it's 3/4 longer, but that gets a little bit confusing if you're not following what I'm saying exactly about the fractions. All right, so now they're going to make your lives a little bit more difficult in that they're going to change the scales of the axes. Now notice in the original one, I just put the original scale here. So this one goes up the same units along the y-axis and the same units along the x-axis. So it's 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. They're about the same. I think they are the same distance apart, and they count by 2s. And now they're going to ask you to graph the same relationship, but now the axes are different. They're different scales. So along the x-axis, notice it goes from 20, 40, 60, 80. So that's adding 20 each time. And the y-axis is 35, 70, 105, 140. So that's adding 35 each time. So this is going to change. So the graph is going to be the same graph. It's just going to look different because these scales have changed. And this is something that'll take a while to get used to, but you're going to see this all the time. Different scales. All right, so here the same graph on 2 different scales. So this ratio is 7/4. This ratio is also 7/4. 70 to 40 simplifies to 7/4, 7 to 4. So the slope is also 7/4, and the vertical distance is 7/4 the horizontal distance. But now look, it doesn't look any longer. It actually looks like it's the same distance. So the vertical distance right here is 70, and the horizontal distance is 40. So this vertical distance is 7/4, 70 out of 40, or 7/4 this horizontal distance. So this vertical distance is more units. It's 70 units compared to the horizontal distance, which is only 40 units. So that's what you have to look at, the numbers and the units. You have to look at the number of units, not the length of the squares, but it's the number of units. This is 1 unit in length and 1 unit in length, but in this situation, in this graph, this is 20 units. Maybe it's 20 miles, and it takes 35 minutes to travel that 20 miles. So maybe this is minutes, maybe this is miles. So they are different values, even though the lengths look the same. So you have to be careful, and we're going to do this a lot to get used to it. So these are the same graphs. This graph is the same as this graph. If you kept going out, eventually you would get to 40, 70. And eventually you get to 80, 140. If you went this way, on this graph, you could find 4, 7, it'd be way down here, and you could find 8, 14. It'd be around here somewhere. And so even though the graphs are the same, they look different. So you still have to calculate the slope. You can't just do it by looking. You have to use the numbers on the scales to calculate the slope. So believe it or not, even though the slants look different on the graphs, they are exactly the same. The slope is exactly the same. It's going to take a while to get used to that. So the graphs have the same slope, so they are the same graphs. They both go through 0, 0. That makes them the same slope. They go through 0, 0. They are the same graphs. They look different because the scales are different. Take a while to think about that. All right, so that is lesson 2, activity 1 from lesson 2, unit 3.